So let's start. The characteristic features of solid. The characteristic features of solids are, yeah, definite shape, different shape, different shape, different shape, different shape, SSD. Let's check. So one answer D. Next, number two. Select the correct statement. Solid, solid water is lighter than liquid. Solid water is lighter than liquid water. Stronger the intermolecular forces of attraction, higher the melting point of the solid. Stronger the molecular interaction. Okay, select the incorrect option. Stronger the intermolecular force of attraction, higher the melting point of the solid. Stronger, yes, correct. Mercury has relatively very low density. Intermolecular distance of separation between neighboring molecule is shorter in solid. It is also correct. This is also correct. So, this is solid water is lighter than liquid water. Solid water means, and what do you mean solid water and liquid water? Okay, solid water means ice, and liquid water means water, simply liquid. So solid water is lighter. Density, yes, because density of ice is less than density of water. Do you know it? So therefore, wrong answer is mercury. It has relatively lower density. No, it has higher. So 2C. Gas liquid conversion is possible at gas to liquid conversion, gas to liquid, high pressure and low temperature. High pressure and low temperature. Answer D. 3, answer D. Yeah. Next, mercury has relatively. So mercury has relatively, because here look, mercury has relatively low density. We get it. Okay, by heart is mercury has high density. Mercury is relatively high density. Okay, high density, high fluidity, high compression. Has mercury has relatively high density. Okay, 4A. So, okay, today we have target of 30 questions, so we have to be fast. So there, oh, in how many minutes? 30 questions in 30 minutes, or in, because these are not so much hard. So 30 questions in 20 minutes. Okay. Let's try. So the of a crystal of crystal dash of a crystal is reflected in the magnitude of its melting point. Reactivity, dissociation, stability. Okay, I think the PDF is not clear. Okay, I take the clear one. So this is a crystal. This is crystal reflected by dash of a crystal is reflected in the magnitude of its melting point. Reactivity of a crystal is reflected in the magnitude of its reactivity of a crystal is reflected in the magnitude of its melting point. The bone dissociation energy. So dissociation, stability. Okay, stability. Answers or solidity. I don't know. 5. I have to look the answer. C. 5C answer. Yeah, stability. Okay, you should know that the melting point is related to stability. A crystalline solid changes abruptly from solid to liquid when heated. Crystalline solid changes abruptly from solid to liquid when heated. solid to liquid, maybe, has no definite melting point. It is wrong. Undergoes deformation of its geometry easily. Has irregular three-dimensional. No, this is wrong. Undergoes deformation of its. No, this is also wrong. Crystalline solid is changes abruptly from solid to liquid. So 6A. Next, number 7. Amorphous substances show short and long range. This is wrong. So short range order have no sharp melting point. This is also correct. So this is wrong. Long range order. This is also wrong. So B and D. B and D. Sorry, D. 7D. Okay, now we have to do fast. Glass is a supercooled liquid. 8 or A. 8 ka A. 8 is A. Oh, 1 minute. Here is given. Look, 8 is D. Why? Oh my god, I don't. These are the common mistakes. So don't do this type of mistake, okay? Mistake. That I don't read these two options. Directly I give that and go for this is wrong. So I lose -1 mark. It means -5. So supercooled is correct, but amorphous also difference is. So which solid will have weakest intermolecular forces? Which solid will have weakest intermolecular forces? Ice, phosphorus, naphthalene, sodium fluoride. Sodium fluoride means NaF. Maybe naphthalene, because okay. Okay, I don't know. Ice has lowest intermolecular forces. Who is the following is a. Okay, I'll also do like this. Okay, this is -1 or minus this. Okay, I'll do. Okay, -1. So which of the following is a molecular crystal? Which of the following is a Which of the following is of following molecular crystal? Which of the following is a molecular crystal? Okay, silicon. This is a molecular. NaCl is ionic. Graphite is covalent. Ice is polar. Answer is 10A. 10A. Oh, 10D. Molecular solid. Oh my god. Molecular crystal. Yeah, because this is what? Polar is also, yeah, this is polar, but polar is. Okay, I'm going to refer my NCERT. First, I'm opening my NCERT and said this. Okay, molecular solids. In molecular solids, non-polar, polar, hydrogen bonded, and ice is H2 ice is hydrogen bonded, so it is a molecular. And Si silicon carbonate, SiC. Okay, SiC is covalent. Graphite and SiC. This is also covalent. So answer is ice. Again -1. So among solids, The highest melting point is established by, okay, highest melting point. Oh, it is ionic. Ionic has highest melting point. Melting point very high, fairly high. Oh no, in NCERT I look ionic point is very high in covalent. So answer 11, look, 11. No, 11B. 11B. Oh, I have written the correct one. 11B. Wait. In the answer, in it is in my book it is given that covalent or network it has very high melting point, and in ionic it is written high only, not very, and metallic solid it is fairly. So I think this answer is wrong. Okay, because in NCERT it is given highest melting point is given very high in covalent network. Okay, so covalent or network solid it is written as very high melting point. So that's why ionic also high I know, but very high is given at fairly high. So I have confusion. Okay, according to NCERT we have to go. So according to NCERT it is very high in covalence rate and is written very high. So this is the answer. So no, this is zero. Okay, the ability of a given substance to assume two or more crystalline structure is, so okay, the ability of a given substance to assume two or more crystalline structure is called two or more crystalline. Okay, ability of a given substance to assume two or polymorphism, two or more crystalline means iso means two substances of same crystal. Isomerism not, answer is polymorphism. Question 12C. 12C. Okay, it is already 12-13 minutes gone. Why I don't know. So the major the major binding force of diamond is, in diamond it is covalent bond. Yeah, 13B. Look, 14. The major binding force in silicon it is also covalent bond. Silicon Si it is covalent bond or metallic bond. It is covalent bond. 14B maybe. Yeah. Then 15. Most crystals show good cleavage because their atoms, ions or molecules are, most crystals show good cleavage. Cleavage means broken. So because their atoms, ions are weakly bonded together. Most crystals. Symmetrical symmetry arrangement in planes strongly bonded together. 15D. Arranged in planes. So I don't know this anything about this. Okay, so these are something. Okay, you should learn the arranged in planes. They are arranged in planes, so most crystals show good cleavage because their atoms and their molecules are arranged in planes. Okay, this is already 14 minutes gone. Okay, let's move to next 15 questions. So this is another 15 questions. The general formula. Okay, now these are important. Actually, I forget to do like this. Okay, the general formula. The general formula of an ionic compound. Ionic compound ionic crystal The general formula of an ionic compound crystallizing in a body center cubic. The general formula of an ionic compound crystallizing in the body center cubic structure is. The general formula of an ionic compound crystallizing in the body center cubic structure is. Okay, I'm sorry. The general formula of an ionic compound crystallizing in a body center. Okay, body center cubic structure. What is saying? The general formula of an ionic compound crystallizing in the body center cubic structure is AB. The general formula of an ionic compound crystallizing in the body center cubic structure. I pause my record. Okay, let's do the next question. If an atom is present in the center of cube, if an atom is present in the center of the cube, the participation of the atom is 1 because it is at the center, so 2B may be answer. An ionic compound AXBY occurs in phase center type crystals with B ion. Okay, occurs in FCC. Okay, FCC. Okay, in FCC type crystal with B ion at the center of each phase. Okay, B ion center of each phase and A ion occupying the corners of the cube. Now formula is, okay, it is very easy, that as B ion is FCC. Okay, FCC B ion at the corner, so corner contribution is 1 and phase contribution is 1 by 1 by phase is 1 by 2 into 6 is therefore 3. So A is with A ion occupying corners of the cube and B ion at the center of each phase. Okay, B is this one, A is 1, therefore B3 A1 B3 A1 B3, as I said 3A. Let's check it. 3A, yeah. A solid. Okay, a solid containing XYZ atoms in a cubic lattice with X atoms occupying the corners Y. X in a cubic lattice, X occupying the corners. Okay, in a cubic lattice with X atoms occupying the corners, Y atoms in the body center and Z atoms in the centers of the faces. Okay, what will be the empirical formula of the compound? So empirical formula. So as X is at the corner, so contribution is 8 corner and contribution is 1 by 8, therefore 1, therefore X1. And Y atoms in the body center, as body center is 1, therefore 1 is 1. And faces, we all know it is 1 by face center, it is 6, sorry, 1 by 2 half into 6, 3, therefore Z3. So look, answer B, for answer B, for answer B, for answer B. Okay, next 5. In a face center cubic lattice, A occupies the corner position and B atom occupies the face center positions, except one. Okay, in a face center cubic lattice, A occupies the corner position. Okay, corner position A occupies and B occupies the face. Okay, it is very easy. A1 B2. Answer is 5A. Look, it is 5C. What is the mistake? Let's see. What's the mistake? 5C. 5C. Why? In a face center cubicle, A occupies a corner. A corner's positions, corner continues was, and B occupies a face center position. Oh, B occupies the face centered position except one face. Okay, except one face. Therefore, 1 by how much? 1 by, this is negative minus 1. So 1 by 2 into 5 face. Therefore, 5 by 2. So what will be final? So A1 B 5 by 2. So multiply both sides with 2. Therefore A2 B5. Is it C? Look. In a face-centered cubic lattice, a unit cell is shared equally by how many unit cells? In a face-centered cubic lattice, a unit cell is shared equally by how many unit cells? So here it is asking a unit cell is shared by how many unit cell? So it is, I think so it is rank, that means coordination number, not rank. Okay, in a factor a unit cell is shared equally by, rank means total number of in a unit cell contribution. So a unit cell is shared equally by how many? So rank, it is not rank, it is a coordination number, face centered cube. So coordination number is 6. 6D may be answer. 6D. Yeah, 6D. Because its coordinate number is 6. Okay, I have some confusion on this. I'm pausing my recording.